Now we will look at an example. So this is for a copper wire. The 12 gauge copper wire in a typical residential building has a cross-sectional area of 3.31 times 10 to minus 6 meters square. Area A is 3.31 times 10 to minus 6 meter square. It carries a constant current of 10.0 amps. The current it carries is 10 amps. What is the drift speed of the electrons in the wire? Assume each copper atom contributes one free electron to the current. The density of copper is 8.92 grams per centimeter cube. Raw copper is 8.92 grams per centimeter cube, and we know that the molecular mass of copper is 6.35 grams per mole atomic mass. And we're told that we will assume each copper atom contributes one free electron, so each copper atom has one valence electron to contribute to the current. So we want to know the drift speed of the electrons. The current I that flows through the copper wire is the charge of each charge carrier Q, charge density N, drift velocity Vd, multiplied with the cross-sectional area A. Now, what is the charge density here? The charge density N is basically 1 mole of copper has Avogadro's number N sub A of copper atoms, and if I divide this by the volume, I will obtain the charge density because each copper atom provides one valence electron. So there will be Avogadro's number of valence electrons per volume of 1 mole of copper. Now, if I multiply this by the density of copper, Avogadro's number of copper atoms and Avogadro's number of valence electrons multiplied by density. Now density is mass per volume, so since Avogadro's number of atoms will be 1 mole, so if I multiply volume with the density, I will obtain the molecular mass, capital M. So molecular mass, the density is the mass per volume. So I multiplied the volume with density, I will obtain mass of 1 mole of copper atoms. Okay, so I can calculate the electron density here, N, by plugging in the numbers. So I have Avogadro's number 6.02 10 to 23, and I have the density of copper 8.92 times, now this is given in grams per centimeter cube. So if I convert grams to kilograms, I have to multiply it by 10 to minus 3. And 1 centimeter is 10 to minus 2 meters. So this gives me 10 to minus 6. So 10 to minus 6, 10 to minus 3 divided by 10 to minus 6 will become 10 to plus 3. So this is 10 to 3 kilograms per meter cube. Then I have molecular mass 63.5 10 to minus 3 kilograms per mole. So this will give me you can see here this will become 23, 26, and 10 to minus 3 goes upstairs, 10 to 29. So this will become, if you calculate it, 8.46 times 10 to 28 electrons per meter cube. That is the electron density. Well, now what is the drift speed here? It is the constant current it carries, I, divided by the charge, Q, number density, N, and cross-sectional area, A. So we know that the wire carries 10 amperes of current. So this is 10. I have the charge of an electron is 1.6 10 to minus 19 coulombs. The number density is 8.46 times 10 to 28. And the cross-sectional area is 3.31 times 10 to minus 6. So this gives me my final answer for the drift speed, 2.23 times 10 to minus 4 meters per second. Okay, so we have a copper wire which has a cross-sectional area A, 3.31 10 to minus 6 meters square, carrying a constant current 10 amps. Because it's copper, density of copper is 8.92 grams per centimeter cube. The mass of 1 mole of copper atoms is 63.5 grams. Each copper atom contributes 1 free electron, so there is 1 valence electron per copper atom. And the number density of the electrons, so if I have 1 mole of copper atoms, there will be Avogadro's number of electrons given per volume. If I multiply this by the density, Avogadro's number multiplied by density divided by the mass of 1 mole of copper atoms, m. So mass of 1 mole divided by its 1 mole of copper atoms divided by its volume will give me the density. So density multiplied with volume becomes molecular mass. It's mass divided by volume. So if I plug in the numbers here, Avogadro's number is 6.02 10 to 23. Density is 8.92 times 10 to 3 kilograms per meter cube. I have to do a unit conversion here. Divided by the molecular mass, 63.5 10 to minus 3 kilograms per mole. And this gives me 8.46 10 to 28 electrons per meter cube. The drift speed is the constant current divided by the charge, number density, and area A. So this is 10 amperes divided by charge of 1 electron, 1.6 10 to minus 19 coulombs. N was calculated here, area was given, and the final answer is 2.23 10 to minus 4 meters per second.